Okay, welcome everyone to Cybersecurity with Python and the Microbit. This is day 1 of 3 on Monday, February 3rd. I'll go ahead and send you a shortcut to the presentation in the chat. Save a copy of this link somewhere, or actually, guess it doesn't matter either way. I was thinking about sending the full link. Here is the short link. Again, I do recommend saving this link because it'll be really good to refer back to if you need links. It has a lot of embedded links, and so I'll be following links to various resources. And so um, um, in some cases, you'll probably note a particular link of interest, but if you remember back at some point and say, hey, I really want to go back to that resource that was demonstrated during the workshop, you'll have a link to the slideshow and be able to get back to it. Okay, one thing I'd like to do is, since this will be a hands-on workshop, we have, I probably have your screen filled right now, or let's see here, yeah. So can everybody see the cybersecurity with Python and the microbit slide that I have visible?
Yes.
Okay, excellent. So what I'd like to do is, instead of having this fill your screen, now for those of you who have more than one screen, there's no need to worry about this. It's only for any of you who have a single screen that you would want to do this. And that is, I'd recommend for those of you who are viewing on a single screen to click the View button and then select Exit Full Screen. That way, my slideshow isn't filling up your whole screen. And what you'll want to do then, so again, you may need to move your mouse around a little bit over the presentation, and then the little View button will pop up in the upper right, and you can click it and then select Exit Full Screen. Once you've done that, I would recommend opening up a Chrome or Microsoft Edge browser and tiling it side by side with the presentation. And for those of you with two screens, I would recommend opening up a Chrome or Microsoft Edge browser and put it on your other screen. So for those of you who have access to your power settings, which is usually in your system tray in the lower right, like somewhere down here, and you may need to click that up caret to find it. If you have access to your power settings, I would recommend setting it for full performance. What that will do is it will allow your computer in most cases to handle the Zoom meeting plus the various demands that our Chrome or Microsoft Edge browser will be putting on the system in order to program your microbit modules and communicate with them. All right, so with you today are Ari Alvarez. He's our company vice president at Parallax, and me, Andy Lindsay. I'm an applications engineer in the education department. Okay, so today we are mid intros and overview, and we'll be using the Python editor for the microbit that's at pythonmicrobit.org and learning how to save and reopen scripts. We'll be looking at some scripting basics. Now, I'm mainly going to show you that the scripting basics exist and also essentially show you how for any of you who are unfamiliar with Python, haven't programmed in Python, I'm going to show you how to learn how to program in Python, but we cannot fit an entire course in Python basics in with the cybersecurity course. So it's going to be kind of an overview of, well, here's a really easy way to learn Python and get proficient with it that doesn't take very long and that you can do on your own. And then after that, we will just talk about how Python is used in some of the cybersecurity applications and how it relates to the scripting basics. And I'll also talk about, pardon me, I'll also talk about a few things beyond basics that are also used in the cybersecurity lessons. And before we adjourn for the day, I'm hoping to that we can all test a 2 microbit connection, basically connecting 2 microbits to the same computer, and then making sure that you can open 2 browsers with 2 Python editors and program the 2 microbits independently, because coming up on Wednesday, many of the cybersecurity examples involve more than 1 microbit running at a time. So they're usually used in the classroom. It's pretty rare to actually need to be using 2 microbits as on the same computer. It's normally we just plug in, each student plugs in a microbit into their own lab computer, or each pair of students plugs a microbit into their own lab computer, and then they'll interact with other students through the microbit connection. There's a big radio network that we'll be creating with microbits. A little bit more about myself. My name is Andy Lindsay. I've been working at Parallax for 25 years now. My background is in electricity and electronics primarily, and so the devices on the device and the little prototyping setup on the right are things that I've worked on recently at varying levels, between under the hood to kit creation to writing documentation for students to use in curriculum. A little bit about Parallax. We are a small company in Central California, just outside of Sacramento, which is between San Francisco and Lake Tahoe. We have 15 employees, and Parallax started in 1988, and and then we started in education in 1997. So one of the things about Parallax is that we have always been focused on how to empower people to do electronic designs. And one of the stumbling blocks, especially early in Parallax days, is something called the microcontroller. A microcontroller is a programmed chip. So somebody programs that chip and then connects circuits to it, and the program inside the microcontroller communicates with the circuits. So for example, on this digital alarm clock, there's a circuit behind each of the push buttons on here, and there's a circuit connected to the speaker inside and the liquid crystal display. And when you press one of these buttons, it causes a change in the circuit. The microcontroller is constantly monitoring for those changes because of the program that was put into it, usually by an engineer at the company that designed the product. And then then the microcontroller will take some kind of action, often by communicating with some other circuit. So for example, with the microwave oven, you also end up pressing a button on the keypad over here on the right. And again, the microcontroller that's inside there detects that circuit change. It'll send rapid high-low signals to a speaker inside the microwave oven to create a beeping noise to let you know that it knows that you press the button, and then it'll update the liquid crystal display and do other functions like turn on relays that allow power to the microwave emitters and the rotating plate at the bottom of the oven, and so on and so forth. So that's the way microcontrollers are used in commercial devices. Microcontrollers are also used to do student prototypes, student research prototypes, and then industrial and scientific research devices as well. And so they're used a lot, especially by students for projects where they're designing and or inventing, and in our case, learning about cybersecurity. Just a little bit more about Parallax. Chip Gracie started the company. He's our chief inventor, and his brother Ken is the company's CEO. Parallax really got off to a big start when it released Chip's invention called the basic stamp. This was back in the mid-90s that the basic stamp came out, and it changed everything about microcontrollers and electronics, because instead of having something that was challenging to program, that required a pretty high level of technical know-how, usually training in engineering or technical fields, microcontrollers got brought to everybody because Chip designed this module to be programmed in BASIC, which at the time was the big beginner's programming language. Since then, many other microcontrollers have entered the easy-to-use market. And two most notable are the Arduino, which kind of came after the basic stamp's first wave. Then there was the Propeller by Parallax later on, and most recently, the BBC microbit. The BBC microbit was commissioned by the BBC to be made and distributed to all middle school students in a certain grade, I think, in Great Britain. So there were north of 1 million of them distributed. So it got off to a strong start, and it was also a design that was collaborated on for education. And so it's a neat little programmable device. The microcontroller that we'll be programming is actually right there on the device. And there's a whole system keeping the microcontroller going. Some of the things that you might notice here are there's an antenna up here. And again, this is the microcontroller. There's a tilt and compass sensor right down here. This is a speaker. This little chip is one that essentially its job is just to talk to the USB port and receive programs and it'll receive communication from this chip and then send communication out. If communication comes in, it'll forward it back. Let's see, radio antenna, battery connector. Then this here on the bottom is some plated electrical connections so that the microbit can be connected to circuits, and programs can be written to monitor and control those circuits. So monitor external push buttons, control external lights, servos, motors, all kinds of things can be connected and controlled through a script and these connections. On the top, there is a fun little 5x5 light emitting diode LED display and a couple of push buttons. The screen, the display is kind of nice in that given a touch interface, those being the push buttons, and a display and a radio and the tilt sensor and all these things, it actually has all the basic ingredients that are also inside a cell phone, which makes it kind of interesting for students to work with. And this site here, this Make It Code It site, microbit.org/projects.makeitcodeit, is a great place to use as a warm-up to just have your students have some fun with the microbit. And I think I would like to do that too. So what we can do is, it looks like I might have linked this to the wrong. Oh no, I linked it to the correct thing. So that was make it coded. I just pasted in, and I'm going to paste in a link to an application, the step counter with the microbit. And so what I would like to do is I'll also paste in the Python script. Now this is the make code block script that's showing by default, but there is also a Python tab that you can use to get the script. And I'm going to copy and paste this into my Python editor. So actually, okay, so I'd better back up a second. I got ahead of myself. So I'm going to send you to python.microbit.org. It'll automatically fill in /v/3 after that. So I'm pasting this in, and so I'd like you to open the microbit Python editor in your Chrome, Google Chrome, or Microsoft Edge browser. So I pasted in python.microbit.org/v/3, and that is where I would like you to go to. And they're going to have a default script already filled in. And before we try out the step counter script, I think it would probably be best to make sure that we can all plug in our microbits and run the default script. So what I'd like you to do is take one of your microbits and one of your USB cables, plug the other end of that USB cable into your computer, and then this end into the microbit, like so. Now, my microbit is running kind of a cool little application where it points down as I rotate it like a steering wheel, which is kind of neat for using to drive robots around and stuff. So that's what it's running right now. And after it's running that, let's just make sure that we can load a program. Now, if you have this default program already running, thanks to having done the homework, just make a change to it. Like instead of image.heart, do image.happy. Or some of your other options, image dot. There's a bunch of arrows. You could do a butterfly, some clock hands, a duck, cow. Just make sure to capitalize the ones that are shown in caps. Happy, heart, heart small, etc. So go ahead and pick an image to display. I'll do heart. And then make sure that you can hit send to microbit. And oh boy, I should, okay. So I'm going to try hitting send to microbit again. I have this set with some convenience settings that I don't actually want. So I'm going to clear my browser cache. Let's see here. Site settings. Delete data, all of it. Okay, so I'll try refreshing this. Okay, so it might ask you about cookies. You could manage the cookies if you want. For example, there's some analytical cookies to help the python.microbit.org coders make sure that their site is working well. And so we could, for example, allow that data to go through. And then after that, there's a nice video here that you can optionally watch to see how it works, or you can just select start coding or hit the X to close out. So now we are here at the blank project again, and I'm going to use the little magnifier up in the upper right by the simulator here just to increase the size of the font a little bit so that hopefully it's visible. And just let me know or send a text if you're having trouble seeing any particular thing here. So just so you know, there's a simulator that you can use for a number of things, and this one we could simulate to see how it looks, and it's going to show us a heart with this display.show image.heart, and it'll do that. It'll hold that image for a second, and then it will use display.scroll to scroll a hello message across our screen. I'll show you how to learn again about these various statements and where they come from and where they're documented, although I can do a little bit of that right now. There is a reference section here. And so, for example, display.show, well, gee, how does that work? Try clicking display, and look at here. There's a little summary of show, and there's even a more button where you can learn all about the little different features that you could take advantage of in the display. I believe this is an object. And then likewise with the image object, they have built-in images that they talk about. You can take a look at the various images. So that's a place where you can look up a lot of these things that you might find in example programs for the microbit. Now that we've simulated it and we know what to expect, we can hit the send to microbit button in the lower left, and it's going to remind us to connect the cable, and we can say don't show this again. So we know that we need to connect the cable after the first time. And it usually warns us that the next screen is going to ask you which microbit you want to connect to. You have to select, even though it's a list of 1 in this case, you have to select that microbit and then hit the connect button. And then, because originally I hit send to microbit, it flashed the code into the microbit. And so what you see here is essentially the same thing that we saw in the simulation, and it's also essentially what the script is telling the microbit to do, which is, in this case, repeatedly, below and indented with this while true, it's going to repeatedly use display.show to show us a heart, and then it will sleep for 1 second, and then it will scroll a hello message. So how are we doing? Let me get my view so I can see as many participants as I can fit on the screen here. How are we doing? Has everybody got the heart or whatever they put in there and the happy face? Go ahead and use the reactions button to give me a thumbs up, or type it into 1 thumb up, 2. Good job, people. 3, 4, 5, 6, 7. Ah, looking great. Okay. And remember, you can unmute yourself if you need to ask a question, or you can type it into the chat. And Ari will be on the chat to help out. And then if you unmute yourself, I will try to help out. So now we will try out the make code example that has the step counter that I started talking about a little while back. Since we know we've got our ability to load scripts into the microbit, I would like you to Oh, that didn't come out. Okay, don't use that one. That came out with line numbers. Let me see if. Okay, I'm gonna hope that after pasting it into the microbit Python editor, that it will strip those line numbers. So second try, paste. Yeah, that looks better. Yes. Okay, so that second attempt at the script, and again, that's from the Make It Code It site, and this one is a step counter that you could connect the battery pack that comes in the kit, and then attach it to your shoe and start counting steps. And if we try sending this one to the microbit, then nothing will apparently happen at first, but each time I shake it to emulate a step, it will increase its step count. Okay, and then now it's displaying double digits, 1, 1, 1, 2, and so on. Now, if you want to restart it at 0, there's a little reset button right next to the USB port on the underside of the microbit. And now I can start over like so. All right, so just give me a shout out if you need if you need a little bit more time. I'm hoping that everybody got to try that. And the reason I selected this one actually is because this short program has all the basics of programming in one script. On line 1, this is where it brings in some of the statements that we're going to use that aren't built into the microbit, or well, there's a set of really primitive Python statements built into the microbit, and from microbit import star brings in all the nice stuff like the accelerometer features and the display features. Now, steps equals steps plus 1 does not require from microbit import star, nor does steps equal 0. But the thing I wanted to point out here is that there's a lot of basic stuff, basic lessons that are reinforced, and I am kind of skipping around here. I will come back to more basic getting started basics, and also how to learn how to program in Python. But I'll just talk generally that while true is, well, there's 5 basic things. There's remembering, calculating, repeating, and deciding, and communicating. Okay, so remembering, steps equals 0. Display dot, that's storing a value. Display dot show steps is remembering a value and then communicating that value. This is where the value of steps is changed every time a motion is detected, and that is calculations. If accelerometer was gesture of shake is a decision, it's saying, well, if the accelerometer told me it got shaken, then do these statements that are below and indented from me. Likewise, while true, which is the repetition part, also does everything below and indented from it. Now, if this is false, it'll skip these things. In other words, if the accelerometer was not shaken, the script just completely repeats over and over again line 4 and 5, saying, hey, okay, while true, repeat everything below and indented from that indefinitely. If accelerometer was gesture shake, well, if the accelerometer was not shaken, it will just skip everything below and indented from it and come back to line 4, which will send it back to line 5, and then back to line 4, and then somebody shakes the accelerometer. So then this becomes a true statement. It was shaken, and so it jumps in here and does these two statements. And again, this is a little ways up the road. So if we go back to the Make It Code It site, so here we are, and it starts with communicate, showing a heart. Beating heart adds in repetitions. Then there's kind of some reinforcement of this with animated animals, and that's cool. Then we have the emotion badge. Now, this is one where students press one of the buttons to show a smile and then another one to show a frown. And that, so we did communicate, then repeat. Now we have decide. And so in program speak, of course, that's communicate, looping structures, and conditionals. Then later on, we come into calculations with our dice, which uses a randomizing feature. And then, of course, the step counter, which increments the value stored in a variable. And that's also where we start using the remember feature. And so with these fun little hands-on activities, students can go through and try out scripts and see how they relate to actual programming. Like I said, it's a nice warm-up. It's kind of fun. Students can try lots of things. And incidentally, there's a lot more down here. For example, if we were to filter for the built-in radio, we will see some activities that use the radio. For example, Tell Me a Secret is one where instead of just pressing the button to see a particular image displayed, when the student presses the button, yes, it will display an image, but it will also broadcast that image, and anybody else in the same group or channel in the program settings will be able to see that image. And that is kind of takes us towards the cybersecurity part, because there can be unauthorized access to and control of the channel. And how do you deal with malicious actors on a network? Much more on that to come. So a little bit about the depth of coverage. We were just at microbit.org and looked at the Make It Code It site. So this is the really basic stuff. And then makecode.microbit.org. So I did point out earlier that some of these lessons that at the Make It Code It site, you will see by default the block code version of it, but you can click the Python tab to see the actual Python script that corresponds to the make code script. And so makecode.microbit.org is another one that's a little bit less deep into the language. Now, when we go to what I'm going to be showing you today, we've got the Cyberbot robot, which is sort of the next level of depth with the microbit. There are some fun AI lessons that we've got to see how you can interact with AI. Well, it's an AI with regards to cybersecurity. So some of the basics are just about using AI as a programming helper, but then and making sure to check your AI's answers and finding out that it can't always do what you ask it for, but also studying how an AI could be fooled into, for example, making a script that provides a backdoor that somebody could add code to a microbit without its user knowing. Then we get to cybersecurity, which these two are kind of, I think, a little bit more interchangeable. I put cybersecurity down below it, and then electronics is probably the most in-depth programming wise. So with the cybersecurity, first of all, there's the cybersecurity came from the cyberbot. So all of cybersecurity is in the cyberbot robot lessons. And then we took the ones where you could do microbit only stuff out, or we made a different set of tiles that you can follow to go to cybersecurity only lessons. This is the, okay. I wanted to mention this workshop, and I think I accidentally mentioned it twice. This is the Microbit for Beginners workshop, and it's worth a watch. It's a 2-hour workshop, and both the slides and the Zoom are oh, that's funny. I'll have to come back to this. I'm not sure why I don't
Going to
see.
paste the link in the chat.
Okay. I'm missing the Zoom link and the well, we can get that. We'll get this.
Yeah, they need to open the on-demand one. The link is on the chat.
Okay. And then actually, I think the on-demand one I have nearby. So for example, if, yeah, just a few slides further down, there's the on-demand workshop link. And I just followed that. And after doing so, here we are. So this is the YouTube session for the Microbit for Beginners. And then there's also the presentation slides. And so those are those slides that have all the links that are followed during the YouTube session. And you can apply for this and get a certificate upon completion of the workshop, or you can just watch the YouTube video and put it on 2x speed and get what you need out of it in short order. Okay, I think I'll get rid of this slide. There we go. So about student versus educator resources, and I'll talk about this again on Friday. Students will go to learn.parallax.com to see the student resources. And that is, I'll go ahead and paste it in. So this is learn.parallax.com. And Cyberbot and cybersecurity are where our cybersecurity material can be found. And I'll show you a little bit more about that in not very long. There are also teacher resources, and that's at parallax.com/educators. And in each of these cases, like if you go to cybersecurity with Python and the microbit, there will be some things that are available out in the open, but the assessment material you have to log in. We'll be sending out homework, or we'll be having you do homework between Wednesday and Friday to get logged into the learn.parallax.com site. And then you'll be able to get to the assessment material. Purchasing. I put in links here so that if you end up being interested in the Cyberbot robot, there's links to a search with the Cyberbot robot category, again, for purchasing's sake, and then also the microbit. This is a search for the microbit, and if I scroll down a little bit here, here is the version 2 club bundle, which is $175 for 10 microbit clubs. And then there is also somewhere further down here, the Go bundle, which is an individual microbit for $18. Close tabs to the right. Okay, upcoming workshops. Here is the link to upcoming workshops. What you will see here is the most, the ones that are coming up soonest, including Microbit for Beginners, which just passed, this week's Cybersecurity, and then next month we will have the Cyberbot robot, which some of you might end up being interested in. It can both extend the cybersecurity lessons and also reinforce many of the computer science concepts. Then we have an education chat in March also. And then if you scroll down to the bottom, you will see the on-demand workshops, and that's where the Microbit for Beginners workshop and an Arduino robot workshop can be found. After this week, we will also have the cybersecurity on-demand workshop for self-paced study following this. And then this again is where the on-demand workshop direct link is, and you'll be able to get to the Microbit for Beginners from there. I went ahead and added just a few articles that talk about embedded systems and IoT, the Internet of Things, and how those are programmed devices that are inside GPSs and those little buttons you hit to order more detergent when you're out that you have mounted possibly by your laundry machine and stuff like that. So all those programmed devices are on the internet, and many of them have vulnerabilities to hacking. They can provide vectors inside to your network. In some cases, they're vulnerable to releasing personal information and credentials. And so I just have a few articles about some of these things that you can follow and read up. And the reason these are here is because the microbit is a lot more like an IoT, an Internet of Things device, than it is a full-blown computer on a network. And this is one of the areas that we think is somewhat underrepresented in terms of cybersecurity and hardening of devices and firmware. And so that's one of the reasons that I think this material is very valuable. Okay, so again, for student tutorials in cybersecurity, we have two places to go. We have the Cyberbot link and the cybersecurity link. And so again, this is learn.parallax.com that we're starting off at. Go ahead and paste that in. Okay, and then I'm going to open both Cyberbot and cybersecurity. Okay, and when I open Cyberbot, what it takes us to is two options. The Python original and the very recent MakeCode version. And so there are now two sets of Cyberbot lessons. One for make code, and where it has the prerequisites, which is some scripting basics. And then it has all the things you can do with the Cyberbot robot. And then it has some extra projects that are done with, in some cases, with sold separately items or items that come in class packs, and also just fun extra things that can be done with the Cyberbot. And if we go to the Python version, it looks rather similar. In fact, I'll go ahead and tile them side by side for a minute. And you'll see that we have our prerequisites, which is the computer sciencey stuff, getting started with the microbit, making microbit programs, computer microbit talk, and look. So that was the make code version. And then in the Python version, getting started, writing programs, adding modules to your microbit is an additional item that is used for the Cyberbot robot, and there is a little blurb on adding extensions that is needed for the Cyberbot robot here. Then there's computer microbit talk, so that's here. Dictionary primer here. Exception handling is not present here. Shouldn't be needed with block code. And then strings and characters. So this is all the as many of the tutorials as possible were repeated in the make code lessons that originally existed as Python. That means that there will be some cybersecurity that you can do with the make code blocks. Specifically, looking down in the cybersecurity area. So this is the last of the robotic sensor navigation stuff with the visible light and the navigation for infrared. Then we come to cybersecurity radio basics. That's how to create a network so that we can emulate threats and mitigations. Then we have cybersecurity radio data. That's an introduction into how data is essentially transmitted and received on a network. After that, we have a Cyberbot tilt control, and there should be some keyboard control in here. I don't see it, but I'm sure I'll be able to find it. Oh, it's probably off to the side. There it is. So there's keyboard control, and then over here, tilt control. So here's keyboard control, and then off to the side, tilt control. So again, lots of similar stuff. And then as far as cybersecurity goes, we have a little bit more. So we have encryption and sniffing and brute force. In the blocks, we only have encryption and brute force currently. We'll try to get more on here. But the reason I brought this up is just basically to show you that it's not only with Python and the microbit anymore. There is the option of using block code for some, but not all, of the cybersecurity lessons. And so right now we have basically the network basics, and then the encryption and brute force, whereas here we have encryption, sniffing, brute force, and then there is also, let's see if I missed anything here. There is also malformed packets. So there's a little bit more in the Python area here. Okay. And then the other thing I wanted to show you was that there is a direct link to the microbit only cybersecurity lessons for Python. And that I just pasted in. And so here we have our computer science and scripting basics, and then the cybersecurity lessons, and then some optional projects if you have a robot. See how we're doing on time. We've got a few more minutes, and then we'll take a quick break. Let's see, close tabs to the right. This one is a nice little resource. What it has is the computer science basic lessons, and this one is for MakeCode. And so each of these tiles, you can click the link to follow it to that particular, we call them courses, but they're really more like chapters. And then each page in the chapter is called a lesson. I like to refer to those as activities. Then there's also the links to the cybersecurity material. And here again, we can see that we have encryption, brute force, and then some robotics applications. So it's a little bit lighter coverage on the MakeCode. And then here I have a slide to all the getting started stuff for the MakeCode editor. And then we have, which incidentally, so that would be like if you followed this link, you would get to the cover page of the Getting Started with MakeCode, and you hit continue, and then you're essentially inside the chapter and going through the activities for getting started with your first script and so on. And then so this is essentially once you're in the Getting Started tile, and then each of these tiles has a chapter like that behind it. And then the same applies for the Python version. And so if you click Getting Started, hopefully most of you have seen this with your homework. Here are the Getting Started links. And so if you follow the main one here, this is the Microbit Python editor. And then there's a Getting Started with that Python editor. And this is where I recommend you start tiling things side by side. Not accidentally off on the other screen. And so, for example, if you continue into the Getting Started, you will see how to load a script, which we've already done. We've already flashed a script, but there's a step-by-step video here. And then all the steps shown in the video are also outlined with little checklist instructions and images and kind of a how-to just below it. And so there will be how to edit a script, how to save changes in your script. And again, there's a video and then step-by-step instructions support, how to save and open changes. There are editor controls that students will likely make a lot of use of. And then there's a serial monitor, which we will be making a lot of use of. And but I will go ahead and guide you through it. But just so you know, this is where the instructions are for using the serial monitor, where you can type commands in your in the monitor using your computer and have them sent to the microbit. And you can also see statements that are printed from the microbit to the computer. Again, I mentioned it earlier, there is a reset button right by the little USB connector. So if you ever want to restart a script, that's where you can do it. And again, when it's hard for me to emphasize enough, if you're new to writing Python scripts, don't worry, just kind of watch and absorb as much as you can from this workshop. But when it comes to learning Python, the second tile up here is called Writing Microbit Programs. And so here is what it looks like when you go into it. So this is the cover page. And then you'll hit continue. And it starts out with the LED matrix. And then the next page is scrolling text. And it talks about how scrolling text works. Then it has some step-by-step instructions for how to run this nice, simple beginner script that will scroll hello across the screen one time. And I'll just show you this. So we start really basic with just scrolling hello across the screen once. And then later on, we add repetitions to that. But here students just go and learn how to do that and how to do pre-made images. And then the thing I recommend for learning is, all right, here we are with an example script. So you'll have been reading along, and the most important thing to do is to actually type in the script. So what I did, copying and pasting, was really not a good idea. So you want to actually type in each statement as much as possible to get a feeling for how the scripting language works. And I recommend this for your students too. And so we can simulate that, and we see a duck. Now, what if I have a mistake in my statement? Notice that a little dot appears and it says IMGE is not defined. And it also has a little underline of where the simulator thinks the problem is. And so we can look at that and look at the code and go, oh, I forgot the A in image. And then we're back to something that will run. Now, one other thing is, even if you do run it with a syntax error, and I'll just simulate this, what will happen is that it will tell you in the serial monitor. And so if I send this to the microbit, it starts displaying a kind of hard to read message, essentially telling us that image is not defined. And we can also hit show serial and then send to microbit. And then we will see that same message, and it's a lot easier to read in the serial monitor. So at this point, it is 4:01, and I would like to take a 5-minute, or it's 1 minute past the hour, 4:01 in California. I would like to take a 5-minute break. Let's say we're starting at 2 minutes past the hour, and we'll reconvene at 7 minutes past the hour. Ari? Okay, welcome back from the break, everyone. I'm going to continue talking about getting familiar with Python scripting language for the microbit. So essentially, we were talking before the break about how it's really best to hand type in each of these examples. So, basically just go through the tutorial, read the explanation, follow the checklist instructions, hand type the script. That's, again, probably the most important thing you can do to have a programming language sink in. And so do that. And then, of course, as you keep reading, you'll find a try this section in many cases where you can try modifications to the script. And again, you'd want to hand type those, and then there's more examples, and often a your turn, which challenges you to go and try something, or do something that does not have a solution, although there are solution scripts in the assessment materials. So that is my spiel on learning the programming language. You don't necessarily have to attend a workshop. You can just try various scripts by hand entering them, reading the explanations, and then experimenting on your own to expand your understanding of how each scripting concept works. That's really going to be the best way to learn a language. So again, this is showing that there's communication, recollection, calculation, decision, and repetition. Those programming basics are introduced in the tile here, the writing microbit programs tile. Then we go on to do a little bit more with computer microbit talk, and then it introduces dictionaries, which are used for exchanging data between microbits, among other things. And then exception handling. If you've ever had a web page freeze on you, it's probably because there was an exception thrown that the exception handler script, statements inside the web page couldn't deal with. So how to handle an exception? It's possible to radio transmit something between microbits, and if it's not something that the receiving microbit was programmed to deal with, that can cause exceptions, can cause the receiving microbit to freeze. And so it's important to incorporate exception handling. And there's strings and characters. That's going to comprise the data that is sent and received. Okay, so let's talk in general about those basics and then move on. So actually, before we do that, I'm just going to paste you a quick little thing, a quick little script that demonstrates those 5 activities that a basic script does, and we'll have you try them out and make sure that it works for you in the serial monitor. So I just pasted that script in, and I'm going to show you what I want you to try with it, which is you'll start by Control A to select all, and then Control V. And if you have a Mac, that's Command A and Command V. And then you'll have your entire script in. Granted, ideally we'd be typing this in and learning it, but with 3 2-hour segments, hopefully this will save some time. And I'm going to actually open a pair of windows with this. Duplicate slide or duplicate tab. Okay, so you don't need to duplicate the tab like I just did. What I'm going to do is use the serial monitor. So I'm going to send to microbit after pasting it in, and then click the show serial in the lower right. And when you do that, it should say hello and press enter to continue. Now, if it doesn't, one thing you can do is, first of all, you'll want to give yourself some more room like I did by grabbing the little handle on the pane separator and drag it upward. But again, if you don't get text, you can try a couple of things. You can hit send to microbit again. And then another thing you can do is hit these 3 dots over here and select Control C for REPL. REPL is a mode where you can type things like print hello and it'll just directly execute it. After going into REPL mode, if you hit send to microbit one more time, it should absolutely display the message at the beginning of the program. So, so once you've got your serial monitor open, this is like a little cheat sheet here. So we've got from microbit import star. We'll need that because of sleep 2000. That is part of the microbit module that we've added to our script. It's extra code that is not native to the microbit. And then we're printing hello. So that's where we see this hello. Then we have input, press enter to continue. And so what that's doing is it's waiting for some kind of input. In this case, in some cases, we load it into a variable. In other cases, we don't. So in this case, all I have to do is press enter to continue, and then it will go to remember, where it'll show us, it'll remember some values. It'll set a variable named a to 2. It'll create a variable and set it to 2 that's named a. It'll create a variable named b and set it to 5. It'll create a variable named f and set it to 1.414. I chose f for floating point because this is a floating point value, whereas these other ones were integers. And then t, I just chose that for text. These don't have to be single letters. They can be multiple letters. Anyway, then it's going to print all those values in a row, and it's going to do that as soon as I press enter. So 25, 1.414, and text. Now it's waiting for me to press enter again. And when I do, it's going to calculate. It's going to add 2 to 5 and store it in a variable that it creates called C. And it's going to print that, and hopefully we'll see the number 7. Okay. Then it's going to decide, is A greater than B? And if so, it's going to print a message. Is A? No, A is not greater than B. So it's going to say, if A is greater than B, it'll print A is greater. Well, A is not greater than B, so it skips that and goes to the next one. Elif, which is a shortening of else if, B is greater than A, it'll print B is greater. And then if they happen to be equal, it would print that they are equal, which is the catch-all not included by these other two statements. So when I press enter, it says B is greater. Good. Okay. When I press enter the next time, it's going to count to 10. So this is the code that counts to 10. And actually, it's only going to count to 9. So it's inclusive for n in range, start value, end value. But this end value, it won't actually, it's actually start value and then 1 before the end value, or rather inclusive start value, exclusive end value. And so it's going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 with 350 millisecond or 0.35 second sleeps or delays between each one. Enter. So again, it printed to 1 below our end value. It printed from our start value to 1 below the end value. Remember that. It's a thing about Python. Okay, and then it's waiting for enter. And so this was our repetitions of a certain number of times. And then this is our infinite repetitions. And when I press enter this time, here we go, 10, 11, and so on into infinity. And so that's a quick little cheat sheet script for the programming basics. And what I would recommend is hitting this untitled project up here and typing programming basics or scripting basics. and confirm. Now, once you've named it, you can hit save. And this is all part of the getting started with the microbit parallax tutorials. And it's going to tell you, hey, we just saved a copy in your downloads. All right, well, let me open up a file browser. And let's see here, if I look in downloads. Okay, here we are. And I'm going to zoom in on this. So here is our downloads, and we see scriptingbasics.hex. So if I instead make a drastic change in the script, I tried a keyboard shortcut that took me somewhere weird. So here I've made a change to the script, and we can hit the open button. I could save it like this, and I could change the name and say that this is the reduced or truncated, and confirm. Okay, and then if I want my original script back, I can hit the open button. And looking in the downloads, there's scriptingbasics.hex right there. And it's asking if I want to replace whatever I was working on, and the answer is yes, and now we're back to scripting basics. All right. Okay, and so I also already showed how to click this little program or script title field up here. Its official name, if I hover over it, doesn't have an official name, okay, or it doesn't have a flyover at least. Anyway, this is the script title, and so you hit script title, and then you can save or open your work. And if you move your work from downloads, you can still open it. You just have to browse to wherever it is in the file dialog. And next up, I wanted to show an application example. So this is from the next chapter, Computer Microbit Talk, and we have input for print applications. And this one is kind of a common theme. And by the way, this tile will take you to the front page of the activity, and you can hit continue, or of the chapter, and then you can hit continue, and then here's some activities. And then this will show you a particular page, the last page in the chapter, where it talks about input for print applications. And this is another one where we're doing all 5 activities or all 5 programming basics in one shot. I'd like you to try it out. So there is the script for you to paste into your Python editor. And if you'd like, you can also copy the countdown timer name and then set the script title to that. And then hit send to microbit. And just to clear out the old data, I'm going to hit it one more time. Okay, and it'll give you an enter number of seconds to count down. And in the interest of time, we'll have it count down from 3. And then a message for after the countdown. We'll use lift off, and the students will have fun with goofy messages there. So this is great. It's an example of bi-directional communication. Here we also introduced that there's text that comes in from the input statement. And so that's a string. And then there's a int function built into the microbit that you can pass it text in between the parentheses, and it will return an integer value, which gets stored in this value variable. And then later on, with while value is greater than equal than 0, as opposed to while true, which we use for indefinite value, while value is greater than equal to 0, every time it checks value against 0 and value is greater than or equal to it, it returns true. And so that's why while true makes a while loop indefinite, but here is a definite version of a while loop. And we could have also used the for loop that I talked about earlier. So for example, we could have done for n in range value comma 0, something like that. And then we could have used that to count down. It would probably look something like this. Counting down by -1. There's a step. You can add steps, like I could count down by -10 if I wanted to, but we'll count down by -1. So hopefully I didn't make any mistakes here. If we hit send to microbit, it's going to ask me for a value. I'll give it 4 this time, and kaboom. Okay, and it's a little different because it counted down to 0 the first time. Like I could have made this -1, and then it would count all the way down to 0 before saying kaboom, or whatever message we put in there. So did everybody get to try that? Please just jump in if something doesn't work for you, because we can do some troubleshooting. Okay, and this is where we took the break last time. All right, functions. I'm just going to talk briefly about functions. And just to tell you, oh, I didn't update that link. Shame on me. Sorry about that, folks. Let's see here. A function is something where you can say def function, and then I print I am a function. And you have to remember to put parentheses in your function. So that's a really simple version of a function. And then I can say function. And we can do it twice if we want that function to be called twice. So in this script, what will happen is that in this script, it'll make a note that there's a function up here. And then when it gets to this statement, it'll say, oh, I need to go find the function named function. And so it'll go up here and find this name and then do what's in it, and then come back and then go on to the next statement, which happens to be another one going into sending us back to the function, doing the job, coming back, running out of statements, and ending the script. And so it should say I am a function twice in the serial monitor. And so there are the two I am a functions. You can also, and this is part of an activity, you could also say that the function will print text for you. Something like that. And again, the tutorial takes you through all this. I'm just kind of fast forwarding through it. And so if you run this, now what it does is not only does it go up and find function up here, but it takes this text that you type and then plops it into this variable that is created for the function called text, and then it prints it with this. And the function can even send you back something like turn. I don't know why this isn't at that same level of indentation. There we go. And so in this case, we're returning a string. We're sending something back after finishing the function. And then essentially you can have a variable to capture what the function returns and then print that. See if this works. Yeah, so here it displays the two messages. And then here it displays what the function sent back. So that's a little bit about functions. And we'll be seeing those. This is just a little reference sheet that shows, for example, that from microbit import star, we're importing the microbit module. That's a vocabulary term. This text that is up here, beginning with a hashtag, is a comment. It's ignored by the script. Display.scroll is an example of the display objects scroll method being called. Sleep 2000 is an example of a function. Image.heart is a property of an object. And so those are just little things for using the right terms to describe something. You can use this as needed. Lists and tuples. Let's see here. Just a quick summary that a tuple is is a list of various values. They don't even have to be the same type, that is put between parentheses. And then you can print the whole thing, that entire list, or you can use indexing. So the name of this tuple is tup, and then the second element, 0, 1, 2, would be high. And so when we print tup of 2, we'll get high. A list is like a tuple, but it's contained in square brackets instead of parentheses. And the thing about lists is that you can edit their elements. So instead of high, you could change that to by. And then when you print the list, it will show you by instead. So that is that's a little bit about lists. And then here is kind of a cool application of lists. And what you can do is this is a list of musical notes. And I'll go ahead and copy this over. Let's see if it makes it into the Okay, I pasted it in, but it's not letting me send this. I'm going to try reducing the number of musical notes that are included. One moment, please. See if I can remove the comment, if that'll let me send it. I still need to remove 19 characters. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Oh, sorry. I will get this sent to you eventually here. Okay, paste. Okay, so I'm over by 140 characters. Okay, I think I deleted enough characters. All right, let's try this. This is an example of a list and how it's useful. This is a list of musical notes. And you won't be able to hear it through my speaker, but maybe we'll be able to hear it on my simulator. And when you try it out, hopefully you'll be able to hear it on your own microbit speakers. Okay. I think I heard somebody else playing it just now. That sounded great. Is mine audible or is it getting filtered?
We can hear a little bit.
Okay. Now, another thing we could try is in the simulator. Was that audible? Okay. Anyway, hopefully you all can hear it on your microphone. Anyhow, that's an example of a list and where it's useful. Basically, this is a list named notes, and then that whole list gets passed to the music.play method, and those notes get played by the microbit, and that's why lists are awesome. And then here's another one. This one, I believe, is from Make It Code It, and it's where you shake the microbit and it randomly chooses a task for you to do next. Now, dictionaries are pairs of items that are enclosed in curly braces. And dictionaries are essentially, in the web, there's something called JSON data, which organizes data into key value pairs. So the name is the key, or rather the key is the name of the value. And so here's a score key and a name key. Well, the name, the value that corresponds to this name is Sir Lancelot, and they're separated by a colon. So name, colon, Sir Lancelot. That's one key value pair, then a comma, then score, colon, 1000. This is a second key value pair. And this is how pretty much everything makes its way around the internet. Whenever you type in something into a search field, it becomes a key value pair before it's transmitted. And you can also, you can say, okay, well, if I name my dictionary info, info of score, we'll go and find the score key, and then it'll give us back the value of 1000, which gets stored in number. And then likewise, you can change a value. You can say info of score equals 1, 2, 3, 4, and it'll go and find score and change its value to 1, 2, 3, 4. You can also create a new, or then you can get a you can get that value back. Now, another thing you can do is you could actually say info of and select some new name, some new key, and then equals some new thing, be it text or a value, and it will append the dictionary with that. And that is covered in Dictionary Primer. So these things that I've been talking about, like the functions and the lists and tuples, are all covered in various tutorials. So here is a dictionaries activity. In the interest of time, I'm going to skip that. Well, let's see here. Maybe if I have it. Yeah, I'll just paste this to you so you can try it out. So again, since we're doing this in a short workshop, we're just really the copy and paste is something that is kind of a necessary evil. And all right, so here we set info like I talked about on an earlier slide. And then here it's printing the entire dictionary. So that's the curly brace, name colon, Sir Lancelot, score colon, 1000. Now, we can also just say print and score equals comma, and that'll print that text, and then info of score, and that's where it goes and finds info. That's the dictionary, and then it finds the score key, and then gives us back the value of 1000. And so that gets printed right here. So score equals 1000. So that's how that works, and we'll be using that a little later on. Exception handling. feel like I updated this and it snapped back to an earlier thing. Let's see if I get a dead link or no, I get a live link. Good. Here is the exception handling primer. And again, this is most commonly seen when web pages freeze, but your microbit can also freeze. And so what I'd like to have you try out is, oh, by the way, so exception handling is you essentially take your existing script and you put statements that might cause it to freeze below and indented from the word try. Then if an exception does occur, there's some things you can do. If an exception does not occur and everything's fine, you might want to do some other things. And then there might even be things you want to do no matter what. So let's start out with a script that could contain an exception. Now, right now, this script works just fine. So I'll have you try it out and make sure it works fine for you too. What this script is it just performs a division, and so it says that the numerator is 20 and the denominator is 5, and then it divides the denominator and the numerator into the numerator, and then it displays the solution. So here is the result. It displays 20 divided by 5 equals 4. Well, that's great. Now let's make it cause an exception. And by the way, the tutorial takes the students through this step by step. I'm kind of doing the fast forward version of it. So let's try making denominator 0 and rerunning it. And we will see that an exception occurs on line 12 where it tries to do the division, because how many times does 0 go into 20? Who knows? You can't multiply anything by 0 to get 20. So so we get the divide by 0, the 0 division error is the exception. Now the problem is that the microbit stopped in its tracks. It did nothing after that. So none of this got displayed. And so if you have a device in your microwave oven or your alarm clock or whatever it's going to be, you don't want it to just kind of stop working for no apparent reason. So that's where exception handling comes in. And so let's try an exception handler. I'm just going to jump to the end and show you. Let's try. Okay. So here is a little bit later in this activity. Copy, paste. All right, so now, by the way, we're adding in capturing text. So I skipped a lot of steps. So we tried it just with that one-shot program, and then we put it inside a while true loop and indented everything. But then we added a try section, and in that try section, the user enters the data and it performs the division. And then if an exception occurs, then it will print an exception, and it'll print the type of exception and what the exception has to say. But that prevents the whole thing from freezing in its tracks, which is important. Now, if an exception does not occur, it prints the result of the division problem. And then remember I said finally was basically no matter, regardless of whether an exception occurred or not, we want to do these things afterwards. And so we're printing try again as a final thing before the whole thing repeats. And so when you do this now, we'll have you just do the numerator as 20 and the denominator, did I paste that in there? Yes, I did. And the denominator is 5 and the result is 4 and everything's great. And it says try again. Now let's try creating the exception. So we'll divide, we'll have our numerator be 20 and our denominator is 0. And then notice that it says, hey, there was an exception. But this time the microbit does not freeze because the exception was handled. It tried it and it displayed the error and we're good to go again. And so if we divide 2 into 10, we'll get 5 and it just keeps working. But if we try to divide, something that's not even a number into 20, we'll get a different kind of exception. And other parts of that chapter guide the students through how to read these errors and give helpful hints to the user. So their final script will tell the user, please enter a number instead of text, or you can't enter 0, you have to enter something that's non-zero for a division problem. Helpful messages based on what kind of exception was detected. And so this is the step where the coder is studying the kind of exceptions that can occur. All right. Got 10 more minutes and 100 slides left. That's terrible. No, just kidding. Let's see here. So this is more about the exceptions and little excerpts from exception handling. And here is the helpful hint, can't divide by 0 at the very tail end of that chapter. Next up is strings, and strings have a lot of features. Strings are contained in quotation marks or apostrophes, and strings are a series of characters normally, although a string can also be just a single character. And there's a lot you can do with strings, all the way up to embedding code into strings. But mainly, there are a few things that we care about when it comes to strings and the upcoming cybersecurity lessons. So primarily that characters have numbers that represent them. ASCII, the American Standard Code for Information Exchange, is a code. And so if you type a number on your keyboard, it's going to send, like if you type the exclamation point, if you type a space, it'll send the code 32 to the computer and the computer will know you hit the space bar. If you do the hashtag, the number 35, and so on through the alphabet, and eventually we'll get up to the tilde, which is the highest ASCII character. And the reason I bring up ASCII characters is because in encryption, one thing that we'll be able to do with ASCII characters, and it's it's related to strings, and if you have a string of length 1, you can use the CHR function, which is one of the functions that you can use for basically checking pardon me, you can use this to convert a number to its equivalent character. And for this, I believe it'll show us all the characters in a nice ASCII table. So you can try that one out. And like I said, there's an entire chapter on strings. Let's see here. And so it shows us the ASCII code on the left and the corresponding character on the right. So there's lots of things you can do with strings, including combining strings. You can, which is handy. There's a plus operator which will connect strings end to end. So instead of adding integer or floating point values, you can just use the plus operator, and it will add one string to the end of another string, so that these three strings here, have a nice and day, will become have a nice day. So what we're going to do for homework is, now let's see, I better at least close one loop about strings. We'll talk about string features here very quickly. So a string, first of all, there's an index. So if I name my string S, I can say S and then 6 inside square braces. Well, that'll go into string. It'll count 0, 1, 2, 3, 4, 5, 6, find that the sixth character is an S, and then it'll return that. So this whole thing becomes S, and then that will get stored in the variable C. And when I print C, well, that'll print a string with one character, S. ORD returns an ASCII value if you give it a character. CHR, which we saw in the most recent example script, gives us a character if we give it an ASCII value. Length will tell us how many characters are in the string, and STR will convert possibly a floating point or an integer or various other types of data. It will convert those to a string. And so here are a few examples. I'll give you a link to this page because it's a nice one that talks about strings and characters. Okay, so what I want you to do for homework is to try connecting 2 microbits to your computer and then run the bidirectional texts script in each microbit. So I'm going to try that right now. This usually doesn't go very well when I try to demonstrate it, so sorry in advance if this doesn't work out. So first off, let's go ahead. It's much easier when we do it the usual way, which is to have every student with their own computer connected to a microbit. So what I'm going to do is I'm going to disconnect this microbit. I just click the 3 dots next to send a microbit, and it allows you to connect and to disconnect. Okay, and I'm going to try connecting another microbit over here to a second serial port. All right. And now I'm going to also copy the terminal chat through microbits into both editors, and then we're going to try to connect to two different microbits. All right, so when we hit connect, or when we hit the three dots and select connect, I'm hoping, yeah, it's showing me a list. And I usually try to remember the last three digits of the list. So I'm selecting 3000 to connect this editor to one microbit, and then the other ended in 000. Oops. Okay. So I don't know whether I connected these to the same microbit or not. So what I'm going to do is go to the web page here and delete all my microbit connections. That's in the little settings here, and I'm going to reload the page. All right, now when I hit connect, I'm not going to select the one that ends in 3000. I'm going to select the one that ends in 5 zeros and hit connect. And here we go. Let's see. Unplug and replug the USB cable, which is actually what I should have done instead of that fancy technique of clicking the website settings up next to the web address. I should have just unplugged. So what I'm doing now is just I unplugged and replugged both microbits. And this time, I think it will allow me to connect to the separate microbits. All right, so let's try this again. Sorry about that. All right, if I hit the three dots next to send a microbit, let's disconnect and then reconnect, and it's giving me the web USB error. So let's try disconnecting one more time for both of them. So I just disconnected and reconnected both microbits. Let's see if that worked. Okay, connect. No. So close and yet so far. What I'm going to do is close both these editors and just reopen the entire editor with both microbits disconnected. All right, so new window. We'll go to the Python microbit editor actually. Okay, and that appeared on another screen. Here it comes. Sorry, we're running just a bit over. I'm almost done because this is your homework. All right, and then we'll duplicate the tab. So right click the tab and duplicate it. And then I need to paste the scripts in. And then we'll try connecting, and then I have to plug in the microbits. Okay, now let's see if connecting to both of them works out. 3 dots next to send the microbit, connect. Okay, and it gives me a list, and on the left, I'm going to select the one with 3,000. Okay, and then I'm going to hit connect on the right. And this time I'll select the one that ends in all zeros. Okay, and then I'm going to flash each microbit with the script. Now, the reason the one on the left is taking a long time is because I had it set up previously to be programmed by the make code editor. And the runtime engine that's inside the microbit is actually being updated by the Python editor so that it works with Python scripts instead of make code scripts. And you can go back and forth, but it takes a little longer on the first time you load a script in. All right, so now if we hit show serial in both of these, I'm actually just going to send the microbit a second time on here since the whole message didn't appear. Okay, I should have made one of these microbit B, but that's okay. The main thing is I have these two connected, and hopefully if we show you the undersides of the microbit, when I type in here, we should actually see some of the, oh, yeah, it's not gonna view very well, but basically we should be able to see some of the serial activity when I type in here. And what's happening is that as I type, it's going to go into one microbit, get sent out its radio, received by the other microbit, and then displayed in the terminal. And so this is what we want to do for homework. I want you to test this and then send me an email if you have any trouble and need some help getting it to work. So I'll type in hello over here, and it just went out the microbits radio into the other microbits radio, and it was received here and displayed. And so I'll type a message back, hi, exclamation point. And so here we have a two-way conversation, nice little chat between microbits, and the students usually respond pretty favorable to this, and they type each other messages. And then we start adding some cybersecurity layers over their messaging. So your homework is to get this running, and I'll send you a nice little set of instructions that's already typed up. And you saw me do it here. So, so we're going to get this going. This is what the instructions look like. And so you'll go ahead and follow along and get it working for yourself. And then on Wednesday, we'll want you to have both microbits connected and running the chat application. So that is it for today. If you'd like to stick around for some open forum questions, answers, and comments, I'll be here for a while longer, and that will be after the recording is finished. And so again, that's it for today. I'll go ahead and email you this homework assignment, and we'll have you do that. Thanks for coming, everyone, and we'll see you at the start of the next session, Wednesday, 3 p.m. Pacific time.